welcome everyone. I know we'll have a few more people coming in and joining us here. We're really excited about the next 90 minutes. We have an incredible group of individuals here from both H2O.ai and Snowflake who will be taking you through a hands-on lab. I'd like to introduce to you Eric and David and Miles, and they'll tell a little bit more about themselves and what you're going to experience over the next 90 minutes or so. My name is Tara, and I'm part of the H2O.ai team. As we go through the next 90 minutes, the goal of our time really is to have this be interactive and give you a chance to ask questions and find answers, and certainly have access to both trial accounts following this event to continue kind of honing your machine learning skills. So we highly encourage you to use both the chat and the QA function throughout this entire event. You can use the chat just to share, hey, this is cool, or hey, I don't get it, I need some additional help, and we have people that are on standby just to answer those questions. Or if you have something really specific or maybe more complex, I'd encourage you to use the QA function. The QA function allows us to kind of track questions very specifically and respond to you individually. So either one, think of the chat as something very social, think of the QA as something that that we can answer very specifically for you. So with that, I would like to turn it over to Eric and David and Miles, and take it away.
Thank you, Tara. Good morning, everyone. I'm Eric Gudgion from H2O.ai, and I just wanted to quickly say hi to everyone. I'm a solutions architect here. I'll be talking to you at the end of the session about deployment of the model, but first let everyone else introduce themselves.
Hello, my name is David Whiting. I am the head of training at H2O, and I'm excited to be able to show you driverless AI and what it can do inside the Snowflake environment.
Hi there, my name is Miles Adkins. I am a partner sales engineer here at Snowflake, and I work with a lot of Snowflake's AI and ML partners to really help that solution acceleration by helping build out joint integrations between platforms just like H2O. And so the goal for today will really to be what we call a virtual hands-on lab, where we're going to let you log into a Snowflake trial account. Hopefully you've already created one. There was an email sent out, I believe, about a day ago. We're going to load some data into Snowflake, create an integration between Snowflake and H2O. I believe David will take it away with showing you off driverless AI, and then Eric is going to show some new cool stuff where you can actually deploy your H2O model inside of a Snowflake warehouse to give you some pretty performance scoring. And so with that, I'm going to share my screen here. Again, this is going to be a kind of a hands-on second here. It's going to be a hands-on session, so I hope you're ready to get going with your keyboard. So yeah, of course, most of you might not have a Snowflake account, and so I'm going to walk you through real quickly on how to get up and running. If you go over to signup.snowflake.com or trial.snowflake.com, we will happily give you a 30-day free trial along with 400 credits to test out the platform. And so it's a real simple, just put in your first name. Of course, I'm Miles. You can all see my corporate email address here, and I work with Snowflake. We can go ahead and hit continue. I would go ahead and stick with the default option here with your enterprise. This will allow you to work with things like multi-cluster warehouses, time travel, etc. In your free time if you choose. The main thing that we'll need to complete this lab is to choose AWS as our cloud provider. The reason for that is a lot of the in-database scoring that Eric will show us later on is currently only enabled for Amazon Web Services. And then you can go ahead and choose the region of your choosing. I'm based out of Chicago. It's a little bit stormy today, so this is why my room's a little dim, but I like to go with US East in Ohio. Check the terms and services. We can go ahead and get started. This will just take just a minute to get that account set up for you. And from there, you just need to navigate over to the email address that you've registered with to get your unique URL deployment that you will use to log into Snowflake. And so I know Google, Gmail can sometimes take a minute with their email fetch. I've already navigated over to mine here, and you'll be presented with an email that looks just like this. You can go ahead and click on Activate. Here you will see your unique Snowflake URL, which will allow you to start to log in. Once you go ahead and click Activate here, you'll be presented with a screen just to create a username, password, and so I've already created mine, but has to be 8 characters long, containing uppercase, lowercase, so pretty straightforward. So yeah, just giving everyone some time to get that going and caught up here. If you've already created your account, great. You have not missed anything yet. If you do have your account already created, feel free to log in, and I will meet you at the home screen here in a minute for your Snowflake account. When you first log in, you should be met with this, pretty plain GUI. There might be a tutorial screen that pops up. You can just go ahead and click minimize. We won't be needing the tutorial today. I'll kind of be here to walk you through everything that you need to know. For those of you that want to get started here, all of the content that we'll be presenting today can be found at quickstarts.snowflake.com or guides.snowflake.com. And this is where Snowflake has gone and created and hosted a bunch of different content, whether partners or customers or our own internal teams have made quick how-to guides for you to just, very much self-service, learn how to use Snowflake. About 3 tiles down in the middle, you'll see AutoML with Snowflake and H2O Driverless AI. And we can go ahead and click start here. We'll basically be going through the entire lab here today. And so, if you get lost or anything like that, or have to jump at some point, you can always come back and kind of pick it up from this lab guide here, again, at guides.snowflake.com. So with that, I'm gonna give everyone just one more minute, hopefully to catch up here if I'm going too fast. For kind of a use case overview today, we'll be doing some automatic machine learning. So yeah, driverless AI automates most of the difficult data science and machine learning workflows, such as feature engineering, model validation, model tuning, and so on and so on. The data set that we'll be looking at and using today and kind of the use case for this virtual hands-on lab is we're going to pretend we're lendingclub.com. Lendingclub.com is obviously a peer-to-peer lender. So traditionally, if you're a normal person and you want to borrow some money, back in the day, you had to go to a bank or open up a credit card, and they'll say, hey, great, we'll give you, the $5,000 that you want to, put up a new fence, but, we're going to charge you 8%, 10%, and so on and so on. With Lending Club, instead of going to a bank, you can actually go to another, just person like yourself who might have some money, who's looking to, generate returns on their money as an investor. And, it's pretty much up to them. Hey, do I want to take the risk on Eric or David to, put up their fence and pay me back? I see Eric, probably not. And yeah, so what's happened is, thousands of customers on each side from the lending and the borrowing have, transacted with each other. And so Lending Club has a rich data set where we have a bunch of information about the borrowee and, did they pay me back? And so what we can do is actually train a model and figure out, what characteristics about borrowers, really attribute to the likelihood of them paying us back. And as an investor going in the future, we can then take those predictions and hopefully make some better decisions. And so again, prerequisites for today, we've just walked through and created a Snowflake account deployed in AWS. Again, the dependency on AWS is really wanting to show off that ability to take the model and score it back in Snowflake in database without having to move your data over the internet. You will need an H2O driverless AI trial as well. This will give you a specific license key for you to kind of activate your model as you go look to score with it. And then again, some basic understanding of data science and machine learning concepts, will be useful. And, the last thing is a little bit of familiarity with, running a Sql statement inside of Snowflake will be helpful as well. But of course, we'll be here kind of to go through that with you. So with that, if we go to step number 2 here, setting up Snowflake, the main file that we'll need for the lab today is available through this big green .sql file button. And so I'm going to go ahead and click on that. Most of the instructions for the rest of the lab here will kind of just be covered, through the presenters. So don't feel the need to kind of follow along and read all this. We're here, live to walk you through all this stuff. So with that, I can see my SQL file has landed in my downloads folder on my local machine. And we will now go back to our actual Snowflake terminal here, where we're going to upload the SQL file, create all the data and storage objects that we need to get some data into a table. And then I'll pass it off to the H2O team to show the capabilities of what we can do with their platform. And so with that, again, we're kind of just here at our basic screen. Again, Snowflake is not really a everything you know about data warehousing remains true in Snowflake. So it's not anything you probably haven't seen before. To get that SQL file into our worksheet here, this is how we kind of execute work inside of Snowflake from the GUI. We can find our way over to this ellipsis kind of on the right-hand side next to your username. And we can go ahead and click on a load script here. I had this downloaded twice, so it's in here twice. But yeah, go ahead and choose your Snowflake H2O vhol _ guides.sql. And what this will do is in your worksheet populates all of the SQL that we're going to need here for the Snowflake piece of the lab. Now, traditionally, you might just execute this line by line. We're going to go ahead and just click on this All Queries button right next to the big blue Run tab. And this will just execute all of the entire SQL statement that we have here. You shouldn't have to worry about creating any virtual warehouses, any database objects. This is all handled inside of our script. And yeah, the main thing is we want to get you guys moving fast. If you're looking for a more slower pace, understanding some of the objects and constructs around virtual warehouses in Snowflake, there's a bunch of other content on guides.snowflake.com that you can go to and figure out how to really get into the nitty-gritty with Snowflake, but wanted to focus on H2O today. So with that, we created a database called Lending Club. we created a warehouse called demo_warehouse. And this is just an extra small. We like to size our warehouses based on t-shirt size, as opposed to, some long string of random letters and numbers that AWS likes to do. And we've gone ahead and created a table called loans. And so we can see here, and this is just a snapshot of the table of all the different characteristics we're going to be able to model on today. So we have, how much was that borrower looking to loan, the term, annual income, kind of all the traditional stuff you think that would probably matter. What's great about this data set as well is you'll notice that there's some, categoricals that we might be able to use. Are they looking to fund their small business, looking to, fund their wedding, looking to pay down their credit card? And so we'll be able to use all of this to actually, predict our target. Is this going to be a bad loan or not? 0 being, this borrower successfully paid us back, or 1, the borrower defaulted. And so with that, we're going to be using H2O today to help us, really quickly get to that answer. I've spent about 8 years as a data scientist, and, just to get a clean data set can take quite a while, to then have to go through all the hurdles of training a bunch of models to figure out what's the most predictive, what features matter, that kind of thing. Really just, you get pretty demoralized pretty quickly. And so, definitely a pro AutoML person. Now, Snowflake will make this super easy for you to get up and running with H2O. We have this icon here at the top right called Partner Connect. What this is going to do is basically allow you to create a seamless integration with a bunch of different partners that have all teamed up with Snowflake for a quick and easy experience. And you can see here we have H2O. Now, the main thing we'll have to do is just switch our role. If you go over to your username on the top right-hand side here, right now you can see we're a sysadmin. If you go to switch role and go to account admin, this will give you the permissions that you need to, basically say, hey, look, I give, this person the ability to start creating connections with partners, which, if you're an enterprise, you might not want to just grant that that process. You'll be presented with a connect to H2O screen. We're going to create some just kind of default, what we call a context variables for you. So a user, a warehouse, a database. And this, again, is really just for good governance. We're not going to use any of this today, but if you're looking to restrict access to a certain user or a certain user group and how much compute they might be able to spend, this is kind of where all that comes into play. And so with that, you can go ahead and hit connect. And you're basically going to get, your partner account has been created and is ready to be activated. And so you can go ahead and click on activate. And this is where you're going to now start leave the Snowflake URL, the Snowflake website, and be automatically ported over to the H2O website. And so with that, I'm going to throw it to David, who's going to now take you through that model building process that we talked about.
So this opens us up in datasets view. And the first thing we're going to do is we're going to come over here and add a data set. And Snowflake has a special connector here that's set up to, we could add one from the file system, but let's add our data from Snowflake. And the way this, my browser has remembered my username and password, but we're going to go ahead and enter the database name here. And the database name is Lending Club. we're going to enter the warehouse, and this is following along with the documentation as demo underscore warehouse. The schema is public. We'll name the data set loans.csv. That's what it originally came from. You're going to need to enter your username and password that came in your welcome email. And then the last thing we need to enter is, this is field optionally enclosed by equals, and now this is a little tricky. It's going to be a single quote, double quote, single quote. And then below that, we're going to enter the query. So this is just a real standard select star from loans. And then I come up here and click to make query. And this spins for a minute, and it is going to be grabbing the data from the Snowflake data warehouse and database. And here we have our loans data set that's been uploaded. Now, once we're in this data set view, we can click anywhere along this line that gets highlighted. And there are a number of different actions that we can take. And so we're going to walk through each of these actions fairly quickly, just an overview, the same way we did it in the start guide. So the first action is details. And what details shows us, this is some nice summary information on the data set that's been loaded. We can see the names, ID, loan amount, term, installment, etc. You can navigate back and forth to the right and the left here. We have some summary statistics, storage type, what the count is, how many missing values we've got, and things like over here we've got bad loan, which is going to be our response. And we see that 15.92% of these loans are bad in this population. We've got min, max, standard deviation, et cetera. So some nice summary information along with histograms or bar plots according to what the data looks like. Now you can also come up here and click on dataset rows. And this visualization is useful just to see what a spreadsheet of this would look like. Again, we're so used to these that sometimes coming to this is helpful, and you can see what the data looks like here. We go back to dataset overview. So that number one is dataset details, and we close this out. We can come back to loans. And the next thing we're going to do is visualize. And this opens up our automatic visualization. And what happens in this automatic visualization is we build a number of different graphs that try to explain in terms of predictive modeling, try to highlight issues that you might want to be aware of. This allows the data scientist to really quickly get a feel for the data. So for instance, we can look at things like, and we create these differently depending on your data set. We can look at histograms that are skewed, and we've got, here's the revolving balance variable. Here is the credit length variable in terms of months. So skewed data can cause issues in modeling, and this just highlights that. So the idea behind automatic visualizations then is that we have a number of different plots that may be of interest here, but unlike a scatter plot matrix or something along those lines. We're not going to show you every single plot, and these here turn out to not be incredibly useful on this one. We're only going to show you the plots that are important for understanding your data. Note so far that this hasn't taken into account. It doesn't know what your Y variable, what your target variable is going to be. So that's AutoViz, and those models live under this AutoViz tab. Okay, so coming back to data sets then, the next task we're going to do as we come down here, we've done details, we've looked at visualize, so we're going to split our data. And anytime you're modeling, you want to create a holdout training data set and the test holdout data set. So we're going to split. Let's name the first train and the second test. And this holdout data set isn't going to be modeled on, but that's the data set that we're going to use to evaluate the models in the final pipeline that we create. So we're going to come here to target column, and we have to scroll down to get to the target bad loan. Now, the reason for selecting the target column is the sampling technique is going to depend on whether that's numeric or categorical. Because it's categorical, we're going to do a stratified sampling here. Come down and let's put our, let's say 80%, 0.8 is going to be 80% of the data is going to be in the train. We'll have 20% as a holdout in the test. I can change this random seed. This makes the split reproducible. If your data set already had a fold column, let's say you were doing 5-fold cross-validation, maybe this is historic data and you want to recreate the same folds, you can reference the fold column here and it will do the sampling correctly given the fold column. If we had a time series problem, we would put the time column here so that the split occurs a long time. So using this data set splitter utility, let's go ahead and click Save. And that will create our train and test data set. Now, the next thing is you'll notice we're going to go to prediction. And this is where Driverless AI really shines, is setting up a predictive model. But in order to do that, make sure that you start on the train, because we're going to do this on the train data. Let's come down and click Predict. And it opens this form for us. And we're going to walk through each one of these steps. So the first thing to do here, by the way, is we mentioned to the train and test data set, come over to test data set, click on this, and let's indicate what the test data set is. Along the top here, we've got a display name. Let's just put in baseline. This is going to be our baseline, our first model we build. Let's select our target column because this is blinking at us. We select target, and remember, we're going to go down to the bottom, scroll down to the bottom and select bad loan. And once bad loan is selected, there's a bunch of stuff that happens down here. Let's talk through some of these other features. If you had a validation data set and you wanted to include a validation split, again, especially if this is historic data, you would start here and indicate what that data set is. Similarly to the fold column we did in the split. So if you've already, that we did in the split functionality, if you've already got a column that indicates which of your k-fold cross validations fold that is, an indicator for that, then you would include it here. Generally in Driverless AI, the settings that we're going to do below in training settings is going to tell Driverless AI which of these two to use. So typically, we're not going to fill those in, but if you're recreating an analysis or you've already done your splits, then you would do it this way. We've got this drop columns column, and this would allow us to drop any of these features that we don't want to be used in this analysis. Let's go ahead and drop this. This description is a text feature. It's a description of why someone wanted the loan from Lending Club. And so to avoid doing natural language processing, NLP here, let's just omit that text field. We'll come down to the bottom and click done. So now we've dropped one of the columns. We have the rest of these filled out. Notice that if we had a weight column, we could add weights as well. We don't in this case. Because the target column was Boolean, right, was a 0, 1, the type down here is Boolean. Here is the count in the training data set with 2 unique values. So it's going to be a classification exercise. And the target frequency, or the number of ones here, is slightly less than 5,000. Okay, so now below we've got some settings here. We're going to talk through what these dials mean in just a second, but there are a couple of things that we want to do first. First off, the scorer. If I click on this, this is chosen log loss for me. Let's change this to AUC. Again, AUC is very popular. We're just using that here for example. You could choose any of those as your particular scorer. The other thing you'll notice is that because this is Boolean, the classification button is automatically clicked. If I wanted to force this to be a regression, I can click it and it will say regression. Let's go back to classification. Oops, and because it did that, let me come back to scorer and select, and there are a variety of scores that one could select here. Let's select AUC. The other thing we want to do in this case is click reproducible to ensure that we've got a reproducible model. This is used both if you want to track things, if you're doing research, if for regulatory reasons you need it to be reproducible, or in this case in teaching, it's you should be getting the same results that I'm getting if we all put it on reproducible. So that's the reason for using it here. Now, one thing before we get into this is sometimes as a data scientist, you might look at this and say, there's not enough control that this gives me. So I just want to very quickly expose expert settings to you. If you are a data scientist, a machine learning engineer, someone that knows about modeling, then this opens up the entire world of, there are a number of different options one can set in experiments. There are options in terms of models. For instance, if I want to, if a model up here says auto, that means I'm allowing driverless AI to decide whether to include the model or not. If I click a model to on, that will force driverless AI to use it. If I click it to off, that makes it not available. So there are models, there's having to do with feature engineering, there's features here. We have some time series and NLP and image specific. We also have recipes. So very quickly, if you wanted to really customize driverless AI, you can click on this official recipes external. And this will lead you, recipes are just Python code that can be injected into the driverless AI platform to do things like, here we'll go under models, algorithms to run alternative models. So if I wanted to run a cat boost model, cat boost has become fairly popular recently, then I can click the cat boost code, and I can go ahead and include that and completely customize. And so recipes, we have recipes for data, we've got recipes for transformers, for models, and for scorers. So you can completely customize things here. That being said, let me close everything we've done there in expert settings. So expert settings gives you complete control over how these experiments are going to be run. So very quickly, let me talk about these three different knobs or dials. We've got one labeled accuracy, one called time, and one called interpretability. And for the most part, what this accuracy knob does is it deals with how features are going to be discovered. So in this case, with accuracy at 5, our feature evolution, we're going to use constant GLM and 2 flavors of gradient boosting to try to discover features, and we're going to validate them with a 1/4 validation split. As I move this accuracy knob up and down, that validation, I may change the models that I'm using to find features, to discover features, and the validation becomes computationally more intensive. In this case, we'd use a 5-fold cross-validation. The other thing that this accuracy knob or dial impacts is what the final pipeline is going to look like. So the final pipeline means that all from data ingestion to feature engineering, all the way to the model. And in this case, the final model is going to be a blend or an ensemble of up to 3 models. If I move my accuracy down low, the accuracy at 2, it's going to just select one of these models. So instead of a blend, it's going to be a simpler model. So this accuracy, you can also think of, I like thinking of it as sort of effort or granularity. The larger my data set, the larger that accuracy dial is automatically going to be set. So the second knob is time. And time is pretty straightforward. Again, time goes from 1 to 10. And time just says how long we're going to allow the features to evolve. So we have this genetic algorithm under the hood, this evolutionary algorithm, where we're going to be evolving, in essence, as 4 individuals, as like 4 different pipelines simultaneously. We're going to do that up to 56 iterations. And we're going to enforce some early stopping rules, which means we're not going to do all 56 iterations. If the model's not improving, if the pipeline's not improving, we will stop. So between accuracy and time, this to a great extent will can determine how long it takes to do an analysis. If we move these both up really high to 10, it will take a long time. It won't necessarily result in a better model. It can, in fact, lead to overfit if we go too high. So driverless AI analyzes our data, and based on the data, gives us some suggestions. So we're going to leave those 2 as it is. This interpretability knob, as the last knob here, really impacts how feature engineering and what constraints are on the model and modeling type and how the genetic algorithm is run under the hood. So one way to think of this is in terms of complexity, right? The least interpretable model is the most complex. And interpretability increasing, we start constraining things more and more to make the model more understandable, easier to explain, et cetera. My kind of favorite point here, my line of demarcation is when interpretability is 7, I get the added benefit of monotonicity constraints. And so that will take something like an XG boost and take it from a black box to at worst a gray box, or to sort of a white box model where I can understand and interpret everything that's happening. Let's put this back to where it was. So we had 546 is what was suggested. Our scorer is AUC. We've got classification automatically enabled. Reproducible, we've selected that. We are on a system that doesn't have GPUs. If our system had GPUs, then this GPU, we can enable or disable them. And let's click Launch Experiment. Now, as the experiment begins, the first thing that happens is we get this nice spinning wheel in the middle. We get some notifications. So Driverless AI tries to tell us what's happening as it's working. You'll see up here at the upper right, I've got notifications. If I click on this, I'll get the full screen with things like it's telling me that reproducible mode is enabled and explaining what that means. It tells me that it's detected imbalance data. The imbalance ratio is kind of slight. It's 1 to 5. It's letting me know that imbalanced models are disabled and telling me in expert settings how to change that if I want to take the imbalance into account. It's automatically dropped our ID column for us, having figured out that that was an ID column and not needed. If that was the wrong thing to do, then it tells us how to fix it. It mentions we do a data shift detection. So across a training and a test set, just to see whether these features, revolving balance, installment, annual income, whether they are, whether a shift in that data has occurred. If the shift is high enough, it will automatically drop some of those features. But these notifications are really nice as far as the data scientist is concerned to understand what the model is doing. Now we've already, let me X out of the notifications here. Driverless AI has already started building models, and each one of these dots is a combination of model and features. And we'll notice this is a light GBM with 22 features. We can see the features on the right here under variable importance at iteration. And our goal is to maximize the AUC. So we're going to allow this to continue evolving, and you'll see that there are combinations of models and features in order to ultimately get the best model. Now, as this is running, a couple of other things to note. If I come to resources and click on system information, this shows me utilization of my CPUs and GPUs if I have any. It shows the amount of virtual memory available. It shows disk usage. This is a really helpful display to check, especially if these things start getting pretty full. That could indicate some potential problems in modeling, but here everything is fine. Under resources, by the way, we also have, if you would rather work from a Jupyter notebook, work from Python, or if your normal working mode is R, you can download those clients and forgo the graphical user interface we use here. You can also click on the help to get our detailed help. So back to the model, let's explain a couple of other things while this is spinning. If you want to see what literally is happening under the hood, we can click on log. And the log here is showing, sort of from a terminal or a logging viewpoint, everything that we're doing. At the end of the experiment, we can completely download these logs and look through them. That's not necessarily needed, but if you're curious or if you'd like to see what's happening under the hood, that's what that log information is for. Now we've gotten to the end. You'll notice we have a notification that feature evolution was stopped early due to detected convergence. So this was our early stopping based on the time being equal to 4. And now we're starting to, we're spinning up, we're training some final models. And you'll notice that throughout here, we have a number of different variables. I've got my ROC curve at the lower right-hand side. If I want to look at precision recall or lift or gains, we could look at those as well, or Kolmogorov, Smirnov. All of those are available to us. Now it's finishing up scoring. At the end, it's going to score here on the test data set. And as we wait another second, it's going to create a document for us. So we're almost to the point where things are finished. And in this case, it's taken just slightly around 6 minutes. It may take equivalent for you, maybe perhaps a little bit more or a little bit less. But we are almost done with this as it's building the what's called the Python scoring pipeline. We've also got it's building a Mojo pipeline, and we'll discuss putting things in production with a Mojo later in this demonstration. Now we're creating the experiment report. And once the experiment is done, it's almost done here, we can once more look at notifications. It's mentioning here, by the way, and this is a really nice feature as well, that we created an ensemble model that according to our settings, and it's telling us that the final ensemble is no better than single models, which gives us the chance to go back and change that to build just an individual model rather than an ensemble. So an ensemble, you're adding complexity without adding performance or additional signal. The other thing, the other knob we can look at here is you'll see something under scores. Oh, there are no scores at this moment, but it was highlighted there. So notice now that we're complete, we have this model with all of its features. If I come down to the lower right-hand side and look at the summary, I can, I have my settings, I can see what the seed was, what my hardware was. I also get a chance to look at down here under feature engineering, 347 features were scored, were tried. 91 of those features were selected for this model. We have the Mojo latency, which tells you how quickly 0.2387 milliseconds that Mojo will score, again, very quickly. Model and feature tuning, we trained 13 of 16 models. Feature evolution, we only used 11 of 84. Anytime this is something of something, that means early stopping kicked in. We get our final validation and test. So the test score here is our true score on our outside sample, on our holdout sample. The other thing we can look at the end here is this is performance on our validation metrics. And here's performance on the test, on the holdout test data set. So we can come anywhere along the line here and get our confusion matrix, get things like false positive rate, true positive rate, accuracy, F1, MCC, all of those. The other thing that happens when we're done, just very quickly, is we've looked a little bit at model performance here. We also get the chance to, let's go ahead following the tutorial, we can diagnose the model on a new data set. So let's do this on test. So test was our holdout data set. This model diagnostics lives under this diagnostics tab. So we'll compute these predictions quickly here. And when they're done, we can open this diagnostic, and this will work for any data set that has the same column set up. In this case, we use the test data set. And you'll see that we have our ROC curve, lift chart, any of these, as well as a plethora of different scorers. And you can pick the one you're most interested in or the one that you want to report out. We can also go ahead and download those predictions. So that lives under diagnostics. Coming back to experiments where this baseline experiment ran, it's the easiest way to return here. So we've done a diagnosed model on a new data set. We can also download our auto report. So for every experiment, Driverless AI creates an automatic report, and mine should be launching here in just a second. Let's see if it launched. Here is the report. So basically what's happened is this is in essence a white paper that has all of the information, all of the settings, information on data sampling, information on your data features, information on feature evolution, what feature evolution recipes or what feature discovery recipes were tried, as well as the feature transformations that were actually included in your experiment. You can see that this is quite a bit of detail, along with the name of the feature, the recipe for the feature, the category that it sits under, and its feature importance. So we document all of that. Here are the validation and test for all of these different models, or for the final model that was done. Again, alternative models, partial dependence plots. So at the end of the day, as we come down, we've created a 57-page document that's reporting in detail the results of this experiment. And that information is extracted from the logs. So that's the most useful way to consume it. If you wanted to, you could download those summaries and logs. Beyond that, we can also visualize the scoring pipeline. Now, this visualization is also available within the documentation, but this is just a quick way to check that, okay, we created a bunch of different features. We had a 4-fold cross-validation with 4 of these different GLM models that were created, built a stacked ensemble out of it, and the outputs of this stacked ensemble prediction were prediction for a not bad loan and a bad loan. So beyond that, the next thing that we're just going to highlight the model interpretation is, let's click on interpret this model. And this is going to, you'll see it start to build. This is going to build a number of different ways that we can look at our model to try to understand what it's doing. So everything from surrogate models, we have Lime and surrogate decision trees, to Shapley values, to feature importance and partial dependence plots. And this MLI is going to exist. This MLI tab is right there. We'll give it just a second to finish up here as it's building these plots. While that's doing it, let's see what is, oh, surrogate models. We're still building a few things. Driverless AI. So let me just show you the Shapley values really quickly while things are building. But again, you get a chance to look at Shapley's, and these are Shapley values in terms of the original features. So we call that naive Shapley. You can also look at the Shapley values for an individual row. So let's say we're looking at row observation 123, and I get a chance to see that individual Shapley values as well. So this is naive Shapley, again, useful to look at. the transformed Shapley is the Shapley value. Let me clear this for now really quickly. Is the Shapley value for the terms that were actually used in the model. So these transformations that were created. So both of those are useful. And this is, let's see how we're doing on surrogate models. We can look at a surrogate decision tree. The idea behind surrogate models, again, is that we're predicting, or our Y variable is the prediction of this complex ensemble model that we've created. And so this is just, we see that the first split is on term, and the next split is on grade, and the next split is on purpose. Why? What was the reason for the loan? This tries to explain at a high level what our model is doing. And here we go. Once things are done, the first place I like to go, and then we'll move on from MLI, is our dashboard. And the dashboard shows me this is a K-line model, a line model on the left-hand side, surrogate model there. This is our surrogate decision tree. I've got my feature importance and my partial dependence plots here. And once more, if we put in observation 1, 2, 3, we can see the equivalent for that individual in gray. This is called an ICE plot, individual conditional expectation. This is the feature importance for this individual, and for them, term isn't the most important. It appears that grade is more important, etc. So, and the gray line here shows what group that individual observation fell in. So again, very quickly, MLI, there's a lot going on here. This lives under this MLI tab. Let's come back to experiment. And once we're here, the next thing we're going to look at is we're going to deploy a model using a Mojo within the Snowflake environment. So just to show you what this is, if I download this Mojo scoring pipeline, there's going to be a file called Mojo zip. And there are two components within that file, that zip file, that we're going to extract. One is called the pipeline.mojo file, and the other one is a Mojo 2 runtime jar file. So I am going to stop my share and turn my time over to Eric so that he can explain the rest of the steps from here.
Thanks, David. So let me share my screen and we'll walk through the deployment part that David got us up to. So what I wanted to, just to recap, I'm just going to move the screen out of the way. Here we go. What I just wanted to recap was where we are in the quick start guide. We're on this section 11 with deployment. And as we saw with on David's screen, we were downloading the Mojo itself. And so the Mojo is a combination of a couple of different pieces that we need to deploy. As was mentioned, the pipeline.mojo, that's the default name for the model object optimized. And you can think of that as a blob of representation of the model. And then the Mojo 2 runtime.jar is the Java executable that can interpret that model for scoring. And as David showed us before, it's very fast scoring when we were doing this through Driverless. And what we want to do is actually take that model and that runtime and deploy it into Snowflake. And that gives us a few really powerful benefits. The first is that we're moving the model to where the data lives. So there's less data transfer. It also means that we can leverage the scalability of the Snowflake warehouse. So as the Snowflake warehouse goes from, say, a small to a large, we'll actually be able to scale the scoring capacity through the scorer as well. The last file we have there, the H2O.ai score.jar, is the driverless scorer code that we have for Snowflake. And so we provide all these artifacts to you. You'll need a valid license that you would have received in the sign-up email. And what we're going to go through and do is deploy that. So the one file that we have actually on our website is the scorer itself. So there's a link here to actually download that scorer. And then what we have done is we need to now put those files into Snowflake itself. So because these files now live on your desktop or your laptop, what we need to do is take them from there and put those artifacts up to the cloud. And so the way we do that with Snowflake is using a Snowflake program called SnowSQL. So there's details here on how to configure that for your environment. There are some configuration steps to download and run that on your local machine. But we provide, one of the artifacts we provide is the SnowSQL to execute. So this is the actual command that you will execute that will connect to your Snowflake instance. So it's a unique instance, your account name. And that's the one you would have received in the Snowflake sign-up. Your username, the database which David was showing us was called demo_wh. The schema will be public, and the warehouse itself will be loans. So once we've put those files up there, we have the put commands here. These ones you can uncomment if you need to execute them, just in case you don't have those on the instance already. But you see, this is where it is saved into a staging table. So the staging table is called Java_UDF_stage. It's a staging table that we've created, and it's in H2O score packages. So we can go ahead and follow these steps to go through and execute that. We continue with creating as much of the SQL as we can for you. So we also have a file called udf.sql, and that contains the SQL that you will need to define the function. The way that looks in your worksheet is you can go into your worksheet and you can say load script. And if you load the script called udf.sql, it will show up here. So you don't have to do any typing. You don't have to worry about getting the names of these features correct. And this will give you everything you need to execute. So what I did earlier in my instance is I uploaded everything I needed, and you can issue this list command that will actually list the staging table, and you'll be able to see that everything is there and in place. The next step through the worksheet is to actually define the function itself. So let's look at this for a second. What we do with the UDF is that the model ends up being a function that any SQL call in Snowflake can invoke the model. So this opens up a whole lot of powerful options. Things like scoring against a table to update some tables, maybe doing things that are unique in Snowflake, like using time travel to look at different rows as they've changed over time and test the model on different iterations, or doing things like using tasks and scheduling this model to perhaps score your customer table at 2 a.m. tomorrow morning. So there's some really powerful things that we enable you to perform in Snowflake once the model is available as a function. So what this will do is I'm just doing a create or replace. My function name is called loans. H2O is called loans. It can be called anything. I'm just calling it this so I remember it's for the loans data set that and model that David showed us being built. And then we have a way to pass some parameters, and we pass an array of the features to the model. This is written in Java. This is a Java function, and it uses a few different files. The ones will be uploaded using SnowSQL. And you notice here that the one thing that you will do is you'll add your license to this. I called mine loans.mojo simply because pipeline.mojo is actually a default name in the system. And it was already gig used, so I didn't want to overwrite someone else's thing in the staging table. So once we have gone and executed that, it will build the model, and this is the handler of how Snowflake will call us. So we can go ahead and execute that, and it will build the model itself, the definition, and then we'll be able to go ahead and call the model. Now, one of the reasons that we do the auto generation and provide the SQL to you in this UDF example file I showed you is that we build the features that are needed for the model. So when David went through and showed us how to build this model using Snowflake, Driverless selected certain columns out of the data and created the features for the model. What we do here is we automatically create the list in the right order of the features that we need for the model to score. And that saves you a lot of time. You don't have to worry about mistyping something or remembering all the features that you need. And especially if you have a number of features like this, you don't have to then type them. So this is a simple SQL statement. We're going to show the ID, which is one of the columns from the original table, and we're going to pass to the H2O score loans method that we just created, the name of the model, which was loans.mojo. You might have it as pipeline.mojo as well in your example. And we're going to pass this array of the features that this needs. So if I just execute this, this line, what will happen is the model is the UDF is created, the data is passed to the model, and we get back the predictions and the ID associated with that row in the table. So this is kind of powerful, right? We're doing this on a warehouse up in the cloud, but now anything that uses Snowflake as a system of record, maybe you have an application, maybe using H2O Wave, can now call a model literally through a SQL call. So anything, any application, anything that uses Snowflake and issues a SQL call can now get a prediction back with the data as well. What we end up doing with that is we provide another example of SQL as well. And this is one of the other files that we have available to be generated. What this allows us to do is to show different ways that we can use some of the unique features in Snowflake as well. And I mentioned a couple of these before, but doing things like, doing a task that will run at 2 a.m. every morning to update the loans with the with the latest prediction. Or you might do this in real time and have an application that issues a SQL call to Snowflake and simply pass a call to H2O score loans and get that back the prediction in real time. One of the things that we find really powerful with Snowflake is, of course, the ability to do backtesting. So what I see data scientists do sometimes is they will say, let's get a prediction of the model that I just created from Driverless that David showed us. And let's also get the prediction from an older model and compare them. And so we were able to see how these predictions change as the data changes and as my model changes, as I get a new variation of my model. So it's a very powerful set of integration that we've created. As David went through and showed us, importing the data into Snowflake, performing the exploration of the data, and then building a model so that our feature engineering can identify features and combinations that help to make the model more accurate. And then providing that explainability so we can explain why the model did certain things, why it was built in a certain way, test out the ideas interactively through the UI that David showed us, and then also generate documentation, the audit report that helps to show how the model was created, and is very good for, especially for industries that are heavily governed and regulated, to have that to, for review. Then finally, deploying it into production. So it's completely standalone now from Driverless. We're not connecting to Driverless. All of the code that executes within Snowflake itself, and it's very, very performant. So as this warehouse scales up, as the data size scales up, the performance of the model continues to perform incredibly well. So I hope that has been super useful for everyone. There's a number of different things that we do with the deployments as well that help you to auto-generate the code. I look forward to hearing feedback from anyone. I don't know, David, if you have any closing comments for people.
No, excuse me. No, I don't. This has been a really nice demo showing all the way from ingesting data from Snowflake, building models, and being able to deploy them quickly. So thank you for joining.
Great. Thank you.